Hello all. Yes, there is nothing being said yet, so we're just currently waiting for a couple more people, and then we're going to start it off. I hope all of you have had a good week. Yeah, we'll give them probably another 67, 70 seconds, and then we'll start off. I hope no one can hear the people shouting outside my room. Great. Okay. 30 seconds. So hello all, welcome to week 3 of Cyber Clinic. It turns out that there's been a lot more people viewing them after the fact than are here live, but we do appreciate those of you that do turn up live. Um, so we're going to be starting this week on a little bit on what's called HPing3, which is a little bit of a continuation, and then moving on to some DDoS stuff. I'm going to warn you extremely, like right now, please do not use anything that you are here in this lecture for anything outside of an educational setting or on your own devices that you have express permission to use it on. People do go to jail over this, and it can be quite a bad thing when you DDoS someone offline. So that's just a big forewarning, education only. So as I say, we'll be going over HPing3 and when to use it over Nmap. It isn't a replacement for Nmap, it is to be used in conjuncture, but it is one of those things that it has its own specialty timings when you want to use it, whereas Nmap is every single engagement, you probably want to be running it at some point. Then we're going to be going on to what is denial of service attacks and distributed denial of service attacks. And then Ryan is going to be taking you through a cross-site scripting full walkthrough, because we listened to a couple of your sort of like feedbacks last week, and you wanted to know and see it being done in real time, and also the thought process behind why we're doing the stuff that we're doing when we are attacking a website or testing for these vulnerabilities and flaws. So HPing3 is sort of like a upgraded ping system. So ping uses what is called ICMP packets. I know I'm going to go a little bit technical here for those that are in year 2 and those that are sort of like a little bit more understanding, but all of you will probably have done, oh, I cannot connect to the internet, and you find some Google article on your phone that says, try and ping this website, or try and ping Google, or ping your router, or something like that. HPing3 just takes that and expands upon its like capabilities. So it can extrapolate better time to response and a lot more in-depth stuff. So you can use your website names with it, but it's best that you use straight IPs. So I've just included a link here to Whois if you're running on a Kali or a Linux box. It's a sort of like a command line tool, and it'll tell you everything about a host name. So here I just did it on the university. It tells you who it's registered to, what DNS service it's registered to, when it needs to be renewed, and when it was first created. And it just sort of gives you real, tangible IP data about things. So it's always better if you run your tools against an IP, just because it's also better for logging and management of where you're getting and where you're putting your scripts. So the features of HPing3 are it's used for testing firewalls, advanced port scanning that is equivalent to Nmap, network testing using a bunch of different protocols. So UDP is your video, TCMP is normally your websites, and ICMP is a special one used for pings. And then, as I said earlier, advanced traceroute can do all the fancy stuff that Nmap can do, like try and work out the operating systems and stuff like that. The reason that it's a little bit more different to Nmap is that it's got its own what's called a shell. So if you've watched Carl's videos in the past, you know that the shell is sort of like what you are typing on. So by default, it's Bash when you're running on Kali or any other Debian or Ubuntu install, and it can change depending on which one you're doing. There are about 5 or 6 common ones, and this HPing3 has its own what is called shell. So you go into the program, so if you can see right at the top here, you have gone into your own shell where then you type out your commands. So here, I just did a very good quick traceroute on the university, trying to find where all of the information are going. The reason that HPing3 is better than your standard like command blind one is it can pick up delays. So if it goes through a switch, most of the time your normal tracerouting software will just bypass it straight through. But the current one, like HPing3, will try and work out if there's a switch. Because a switch doesn't actually act on the data, it normally just gets passed straight through to the next device, and that doesn't always show up in your trace routes. Whereas HPing3 can sometimes try and work it out. It's not 100% accurate, but it's a lot better than a standard one. So I'm not going to go through all of the switches and stuff like I did last time, because I got a little bit of feedback that they were a little bit in depth and stuff like that. So I've just included a bit.ly link, and Carl is going to be placing the actual ones in the chat. So this is what's called a man page or a manual page for HPing3. So your manual pages are basically your documentation. If you have any questions or aren't sure what a switch does, go to the manual page. So I've just included it here so you can look through that at your own time and have a look and see if it is any other thing. It's great for checking the right information for any tool that is on Kali by default. Yeah, if you are on it by default, you can literally just type man and then the command you're looking for. So man HPing3, man burp suite, man whatever you want, and it will try and help you and give you the full page for it and tell you this is how you would use it. These are the switches it likes. These are the ones it doesn't. And then it's great for checking the information. So HPing3, as I say, has some better use cases than Nmap. You can do it with Nmap, but it gets very complicated with what flags and what switches you need to use. So HPing3 made it quite easy for us if we are trying to scan, for this instance, a HTTPS website, so a secure website. So this -8 is, as again, we need switches. The man page tells you what switches do, turns it into a scanning mode. So I am scanning port 443. And the host name, as I say, Northumbria. This is a little bit more information than you get with Nmap. Nmap identifies the services and the programs running on it. HPing3 identifies what flags are open and what IP protocols are running on it, if that makes sense. I know I'm going technical again, but it's not at the end of the world. You will be learning this as you get a little bit further on in uni, and then you can come back and watch the videos again. So these flags here are what you are sort of looking for in the context of us on this presentation doing a DDoS attack. So as I say, don't use this for anything malicious, but we can see that they have the SYN flag, which is the open connection, and the acknowledgement flag, and then a time to live that isn't overly informational, and then the length and everything like that. But it's these flag things that if you are looking to run a DDoS attack or work out if your system is protected against a DDoS attack, that you can check. So here we have a DDoS attack that is running through HPing3. I have gone and broken down all of the commands so that you can see which one is each doing. So we have HPing3 how many packets to send. Always set a limit on your packets, even if you are just trying to knock a server off or your own machine offline. Always set a limit so that eventually it will come back up. Because if you give it an infinite amount of pings, you may be unable to stop it. So it is that thing of if you are testing on your own stuff or testing on a commercial service that is giving you full express permission, always make sure that there's a way to turn it off. That may even be just unplugging your network port. That is the technical solution and it works every time. Here, we're sending a packet that is slightly larger than normal. So here, it's expecting to see a packet length of 46. You can send a bigger one all the way up to about 6,500 bytes, but then that gets triggered by a lot of anti-protection system and intrusion prevention systems. So keeping it a little bit larger than standard, but not super large, is also helpful. This -S is the thing that we are looking at from our previous scan. So as I said, it accepted SYN packets right here. So we are sending them to a SYN port. We are sending, again, slightly larger file size, but this time we're sending it to port 80, because if we send it to port 443, it will most probably have port 80 open as well, and you can do the same. Flood just means if you've got a gigabit connection, use a gigabit connection. If you've got a 100 meg connection, use the 100 meg connection. So this is why we include the count, because if you fill up your entire count, like if you fill up your entire network port and you are logging in via something like SSH or something that is network based, you may just completely crash yourself out and be unable to get back into the server. And then this RAND source is what is called obfuscation. So if all of a sudden a system sees, oh, I've got 1 million pings coming in from this one IP address, most computers are smart enough to say, I don't know. Oh, is my cursor not showing up? Right, I'll fix that for the next stream. But in the middle of the screen, I'm on about the SYN flag, which is the s.s. .s. That might help you out if you can't see my cursor. But
Matt, there's a like a red dot pointer thing in the bottom left tools menu. No, in PowerPoint.
Oh, is that?
Yeah, it's like a laser pointer thing.
Does that work?
Laser pointer. There you go. There you go.
Yeah. Yep. Okay. So I'll go back a slide. Here. Sorry about that, guys. Technical issue. But this SYN flag is what I was on about. So as I said, we are seeing that it is open to SYN packets. So therefore, we are sending SYN packets to it, if that makes sense. So we are sending out the packets as fast as possible, and we are also sending them out from a random IP address. So it just puts in a random number in the source address, so that things that are attacking or looking for attacks don't see it coming from one IP, so therefore it's harder to trace. So we're now just going to move on to a little bit about DOS and DDoS attacks that aren't run through HPing3. So what data can be a target? What is it? Why do people do it? Real-world ones, like attacks that have been recorded, and the mitigation strategies that they employ to prevent it. So, by definition, denial of service attacks are an interruption to a computer network or service. So when we say service, we mean you might be able to log on to your file transfer site or something like that, but if you can't do something on it, like you can't upload a file, but you can download fine, that's still interruption of the service as a general thing, instead of just the entire network. So when we're talking about our data, we are talking about websites, VPNs, file storages, video streaming, anything that uses a network connection or you need to be able to use a network connection to get to. That can be considered our data that our DDoS attack will prevent. So most of the time it just slows down a website because that's what we're testing on, because we aren't going super in depth and attacking real services, but it can happen. So, and our connection speed is our bandwidth. You probably all know what that is, I would hope. Megabyte, megabit, everything like that. So it's great for sort of like knowing that if you send a gigabit, it can only receive a gigabit on most networks because you are using local machines to test this. And it means if someone is using up 50% of your network data, it means there's only 50% left for the rest of the users. And I will use liquid as a term in this as sort of like a metaphor, because a lot of people can understand when you're saying liquid and stuff like that, but not all of us have a deep understanding of what is a megabit, megabyte, gigabyte, terabyte, all that stuff. So there's two main kinds of DDoS attacks, or DOS attacks. There's your volumetric ones, which are slowing down the download by sending a lot of clients and a lot of data at the server, slow down the download, and your application ones. Your application look like a lot of real users. They open up sort of like ports on the network and say, "Here, I'm over here, I want to receive some data," and then they just don't do anything with it. So they use up all of the upload that the server has, if that makes sense. So why is it done? Money. If people do a DDoS attack at the right time, so if you think about the Grand National or like some of these other big racing, gambling, sporting events, if all of a sudden you knock a gambling website offline during these peak trading hours, they can lose thousands upon thousands of pounds, which obviously for them isn't great. And then again, not just betting companies, some other companies have specific times like end of week or end of the month where they need to submit all of their forms for buying stuff and stuff like that, or sale orders. If you knock them offline during that critical time, it can be quite bad for them and they can lose a lot of money. Your most common reason is probably going to be your axe to grind. So quite a lot of companies might do testing on animals, let's per se, and then people will go after them and knock them offline because they don't agree with the values of testing on animals or something like that. This happened to SeaWorld a couple of years ago, where people just kept DOSing them offline because of the way that they were treating some of the wildlife that they were picking up and putting into SeaWorld. Again, with some of the anonymous users that were involved in that got jail time. And then literally any reason you can think of is one of the other ones. It's quite common for script kiddies and stuff like that to knock someone offline because they killed you once too many times in a video game. As Carl says, old days of Xbox were completely filled with this when people's IPs were on plain text and just if you monitored the network flow going in and out of your computer or your Xbox or whatever, you could see them, point them at a tool, it would knock them offline. All of a sudden they can't kill you anymore because they're not in the server. So I'm just going to be covering over a little bit of ping, just to give you a little bit of background into HPing 3 and some of these attacks that I'm going to be going into a little bit more detail with in a minute. So as I said, most troubleshooting guides have you need to be able to ping this server to help us work out what the issue is. So ping is what is called an ICMP packet. There are three main kinds of packets. You've got your UDP, which doesn't confirm that it's been received, so it's good for video, because you don't need every single frame of a video or something like that for it still to run. You've got your TCP, which is mostly your websites, your gaming servers and stuff like that, because you want to know that you've made a connection to the server, you've got the correct data to or from the server. So for stuff like websites and stuff, if you are logging in, you want to know that your logon has become validated, so it receives a reply. ICMP are special. They have a lot of timings built into them, and they do respond. So they don't confirm that they've been responded to, but they are sort of like great for establishing timings between servers. So here we have just an example one of what it looks like from your command line. Size of the byte, 64, and this is quite important later on. How long it took there, what number of packet is, so it's sequential, and the time to live. So if it takes longer than 56 seconds or 56 milliseconds, depending on what kind of time to live you're looking at, it will then just shut itself down. So in this case, the time to live is 56 milliseconds, and if it takes longer than that, it says the port wasn't received. So some of you will be using Wireshark within the current months and stuff like that. This is an extract from what is our actual network flow. So if you run this when you're playing a game or whether you're connecting to the internet, watching YouTube and stuff, you will see a lot of data coming through this, whether it be TCP, UDP, all of that kind of data. This is a program called Wireshark, and it's meant for Windows. There is also a Linux version, but this one is primarily Windows based. Yep, so Patrick's saying that you did Wireshark this week. So there is an actual reason for it. It is all about how to monitor your network flow. So here we're just pinging back to another computer on the network. And as you can see, the data's doubled. So if I send one thing, I get two, technically, responses. And it's just one of those things that it's nice to be able to see when you execute a ping-based flood attack. So basically, a ping-based flood is pretty self-explanatory. You are flooding their computer with pings. Everything is named rather simply in this. So it is very, very crude. It is very, very easy. If you are doing it over the internet, it doesn't work very well at all. You have to be within the local network of the computer you are trying to attack. So this is great for testing on computers that you own that are sat right next to each other, plugged into the same switch kind of thing. It produces double traffic, so it is quite effective if you are just trying to use up as much data as possible, but it is very easily blocked. So distributed DOS, or distributed denial of service, is most common because a single computer can only output as much data as maybe 1 gigabit if you are on a LAN network, or if you are attacking a website or something like that you have been hired to test. You can only output as much data as your network will allow you to upload. So your internet service provider might cap you at, let's say, 15 meg or something like that. You cannot upload more than that, and a lot of these servers that everything is hosted on have probably multi-hundred megabit or maybe even gigabit connection to the internet. So they have more of an impact because there are more of them. So if you think of 10 attacks going 10 meg, all of a sudden you've got 100 meg. If you amplify that up to sort of like 6,000-7,000 boxes, like scattered all over the world, all with varying upload speeds and everything like that, you can get a huge amount of data incredibly quickly. And because they're coming from all over the world, they are much harder to block. If everything's coming from one IP, you can say, oh, ban that IP. All of a sudden, it looks like there's thousands of users hitting your site. It might all be legitimate traffic, but you don't know. All of a sudden, it's incredibly hard to block all these thousands of IPs because there are some legitimate users in there. And these slave boxes are called zombies. They normally all call back to what is called a command and control server, and these will sort of like coordinate the attack and send it straight out. So Patrick is asking, IoT stuff is bad for zombies and boxes and stuff like that. Yes, they used to be incredibly bad. You could create a whole botnet using Alexas and Google Homes and stuff when they were very, very early on, but they weren't good. Like, yes, you had maybe 50,000 devices, but they were all very limited in what they could do because they don't have full networking stacks, or they don't have the same amount of processing power, and they couldn't send the same amount and volume of information because they're only meant for sort of like streaming a bit of video or a bit of music or something like that if it was one of the early ones. Like nowadays, if you manage to get a full-blown IoT botnet, it would be very, very powerful because all of the technology has now been updated, but that's still why most of us in the cybersecurity industry run our IoT devices on completely separate networks and Wi-Fi's, just in case this happens. I think Ryan's just posted a link if you're interested later for something very similar to this, where you can go and read up a different botnet that use this kind of features. So IoT botnets are bad, we get that, but that is more of a dumb botnet. They send just their volumetric information. They are that volume attack that I was on about earlier. HTTP post attacks are slightly more clever, I'll say that, because they are exploiting the way that the system works instead of just a huge amount of bandwidth you can throw at it. So these are made to seem like real users. These are application attacks, and these, what I'll do is call to a server and open a connection. Because as I said, when you are connecting to a server, you want to make sure that your data has got there and you are receiving the correct data back. So you are sort of wanting to make sure that you have a reply, which is your TCP stack. You will be learning about this more in network, so don't worry about it if it's a little bit too confusing at the moment. But if you open up a website and you send a single byte of data every 100 seconds or something, this is why I was on about a little bit time to live. If you send them at literally the edge of the time to live, so if I go all the way back, so this one has a time to live of 240. If we send them at 239 seconds or 239 milliseconds or whatever that time to live is, we will be able to keep refreshing our network connection. So it uses up one port on the network in a NAT table or something of like that to stop the data being able to go through. So if you all of a sudden create 65,000 of these, because every computer can open up multiple instances of a request to the website, all of a sudden you can fill up what is called a NAT table or a network translation table, or more often than not, you fill out the RAM or max out their CPU or the amount of processes that the computer can actually run. Because if you think about your little network router that's sat downstairs that is like your internet provided one, some of those only have about 100 megabytes of RAM, maybe 256 if you've got a fiber connection, unless you are running your own custom built router. All of a sudden, if you think about it, it's using so much for your operating system that it's running that is Linux or something off of Linux. All you've got to do is max out that extra maybe 40 megabytes of RAM or something, and all of a sudden, you can't figure out how to prevent this attack because you've got all of your connections that are attached to your server that say, oh, we've run out of RAM, I'm just going to crash. Or if you fill up a NAT table just because you have so much false traffic, if a legitimate user comes along and says, hey, can I have some data, please? It says, no, I've got no space, you'll have to come back later. And that's why you'll used to get some of those websites that say, oh, cannot get in, please try again later, or we're experiencing too many users, please come again. Like that kind of thing used to be because NAT tables are filling up. So it's useful when a target has a large amount of bandwidth. So if you think about they are running through Cloudflare or some of these big other DDoS providers, they might prevent straight up volumetric attacks, but you might be able to max out the server that they're sat on. So here is just a bit of an extract of a script that would do that. So we have a custom written post request. It's going to keep the packet alive for 900 milliseconds, so basically a second. And we are maxing out the length just to try and fill up as much RAM as possible. And it's just going to iterate through this, make 256 connections, and use a custom written user agent. So a lot of websites and stuff, when they are trying to prevent people being able to do this, they are looking for user agent strings. You will cover this later, so I won't go into it, because you can get very complicated with these, but just know Google has one, Firefox has one, literally everything that connects to the internet might have your own. You can bypass these, but they aren't like you just put in a different user agent or just completely bypass it altogether. So how would we prevent an attack like this? So a HTTP post request is quite basic when you break it down. Someone connects to your server, they slow down their network connection, they connect to your server, they slow down their network connection, and just do it over and over again. You can just say, oh, if a user has been connected for 15, 20 seconds, and we still haven't received a full amount of data, kick them off. Nowadays, with everyone running on fiber and stuff, you can turn this down depending on what the service is. So if it is basically just a full web login form, if they are taking more than maybe a second, 2 seconds to log in, just tell them to, oh, sorry, couldn't validate your login, try again. So that kind of thing. If they are connecting using a IP address, like a WAN IP address, you can limit it to, oh, if you are connecting from this IP address or like something that isn't a business IP, you're only allowed to connect 5 different ways to our server. You're allowed 5 tabs open before you aren't allowed to open another one. And this is another one that like is really useful for sort of like prevention of most of these DDoS attacks, because most of them send a bunch of users or fake users and a bunch of data at your system. All of a sudden you just say, oh, you've exceeded our cap, please relog on, or something like that. So moving on to some of those LAN-based tools or personal use tools that you are testing against internal websites and stuff like that. And these are the ones that you will have seen in the news. There are much more better ones built into Kali and stuff like that. But these are sort of like your Windows ones that you will have heard about in the news if you were growing up in the last sort of like probably 5-10 years and been in the security scene. So we have low orbital ion cannon, or LOIC. It was brought to us by in 2010 by Anonymous. It wasn't designed by them, but they made it like a massive, massive thing. And they have to run a single iteration of this on every machine they wanted to use. So it wasn't a complete DDoS tool because it didn't call back to a central server. It didn't do anything like that. They just had hundreds of users that said, oh, we'll point our LOIC at this thing for an hour during this time. And it worked because there was such a large volume that it worked. So it made no attempt to hide itself. It didn't try and say, oh, I came from this IP over here, I came from that IP. It just sort of said, I am going directly at this thing straight away. And it was very easy to block because all of a sudden you had 47,000 attempts a second to connect to your server from a single IP address. IPS, IDS, so everything like that just went, nope, go away. 13 members of Anonymous were arrested in 2010 for using it. And there's a great sort of like podcast on Darknet Diaries about one of the guys who was arrested because of this. But you can only run one instance at a time. So then they went away and they made a new one. So this is the user interface. Everyone liked it because it was written in VB script and it was very easy to mod to their heart's content. And they made pretty little graphic user interfaces and went, haha, I am a Bert elite hacker, and used this instead of using a command line tool. So Orbital Ion Cannon is the upgraded version. So it used to be able to hit 256 URLs at once. I think they upgraded this again to 512. And then all of a sudden, they built in obfuscation. And as I was saying earlier, obfuscation is a way to make it so that computers and IDS, IPS, when I talk about IDS and IPS, I'm talking about intrusion prevention systems and intrusion detection systems. They do two very different things, but I will talk about those later in another video as well. So by default, it sends and randomly picks one of 25,000 different user agents. So as I was saying earlier when I was talking about HTTP PostScripts, and Ryan is going to potentially, if you want him to, talk about how to bypass and change your user scripts. But by default, it has a list of 25,000 and it'll randomly pick between them, along with randomly picking the IP address that it comes from. You only need about 50 of these machines, so about 50 instances, before you can crash up to gigantic mega corporations. So this is what the Heric sort of user interface looks like. It is a lot more simple, a lot more streamlined, and it literally is how many targets you want to add. You click your plus or minus buttons, you add a URL in, you click the plus or minus buttons to add and delete them, and then you click fire. Turn up how many threads you want. If you have a very good computer, you can probably turn this up to about 6 before your computer crashes. Other than that, keep it pretty low. But again, this is only for educational purposes, testing whether you put in some kind of proxy server on your own website or your own local domain to whether these do or don't work. So please do not go out and use this anywhere else. But as I say, when you get a bit of money behind you and you start looking at DOS attacks and stuff like that, they can be quite easily blocked. So earlier this year, Amazon defended against the largest one ever made, which was 2.3 terabits per second, or the size of Call of Duty Modern Warfare with Warzone and everything like that every single second. They were defending against that because it was such a large attack from all over the world. So, as I say, that is a huge amount of data. Everyone laughs at Call of Duty for being a massively big game. Imagine having that shoved at your server every single second. Like the entire copy of it. It's insane. GitHub actually produces all of their own graphs and everything to show you how they mitigated it and everything like that. So, this bottom one is what was their live attack. So, all of a sudden, you've got your average use of probably maybe 20, 30 gigabytes a second. All of a sudden, you are jumping up to over a terabit. All of the GitHub engineers went, well, something's not quite right there. But it literally managed to migrate well, not every single bit of DOS attack, but it managed to get like 98% of it. So the servers just continued to run completely fine. They were a little slow, but you managed to mitigate all but about 50 gig. 30 of that was legitimate use, and 20 of that wasn't. So all of a sudden, they just thought that they had double the amount of users, so the services were a little slow, but they still all worked fine. And then it went back down to the normal range. It can be completely mitigated, but it is incredibly difficult to mitigate everything completely, and not every website is immune. This was what is called a live attack map of DDoS attacks in the world. So This was back in August 2018, and this was about 600 attacks that were going on in the world, and it was one of the biggest that I'd ever seen at the time, which has now been completely dwarfed because I logged on yesterday, and there was 1.2 terabits going out to Canada. But this was sort of like 12 gigabytes a second heading into New Zealand to a single server, website, VPN service, whatever you want to call it. And this was definitely not sanctioned. So we keep saying whether they are or not sanctioned, like if it's a company testing whether it's or not your DDoS protection works. That's what we mean by censored if you give them permission. This wasn't. They were uploading 40 meg, downloading 12.5 gig. So this, when I'm talking about like bandwidth blocks and water and stuff like that, this is like a dam. This is a full wall of data that is basically impenetrable unless you are running specialist systems that are meant to get around your IDS, to prevent your DDoS attacks like IDS and IPS. These DDoS things can be rented. You can literally go on the darknet, type in a couple of darknet searches, and go, oh, how much? Oh, it's 0.3 bitcoins for a day. That's actually an exaggeration. They're much cheaper than that, but it's that kind of thing. And you can just go and rent one for a day, 2 days, a month, whatever you need, and go and test legitimately on your targets when they give you full permission. These are the kinds of things that they were intended to be used for. But then again, if you are a bad hack or a black hat, you can go out, rent one of these, point it at the server that you don't like, and try and DOS them offline. Or you can make your own. So you create your own little botnet, you create your own little command and control server. You will never quite reach the same amount of data, because to be able to do that, you have to have either got permission from the people's systems that you are running your DOS script on, which normally most people won't give you permission because you say, oh, can I use your computer for a couple of hours whilst I DOS people? No, that's not going to happen. Or you have to do it illegitimately. So you have to go and hack someone and try and get them to install your script maliciously, that all of a sudden we're breaking the law and we can't do that. So all of a sudden, trying to test whether DOS or DDoS protections work is very, very difficult and very, very grey in the eyes of the law, unless you are renting them for a specific use. But even if you are renting them, some governments and some companies and stuff will say, nope, because it's illegal to be buying services off criminals. It's just very, very dependent. Most of the time, if people ask you to do a DOS and look at their DOS protection, only do it locally from your own machine with express written permission. If they say, try and do it over the internet, no, it's just too risky. So how do we detect them? So without these systems in place, like IDS, IPS, firewalls, all that kind of stuff, it's very, very difficult. You might be able to tell because your website's lagging a bit. Like normally, you can click through all your pages and it takes maybe half a second to load or something, and all of a sudden you're clicking through and it takes 2 or 3 seconds to load, and you go, that's a bit weird. Wonder what's happening. And then, or just some parts of it. So if all of a sudden the whole of the website's fine, you try and upload a file or a YouTube video or something like that and it's lagging just on that one particular part, it might be because that one particular service, which I was on about earlier, whether it be your video, live streaming, anything like that, or your file transfer, is under attack by an attack. But the rest of the other stuff, like your basic web interface, your GUI, your port 80, port 443, they're completely fine. They're not being attacked. That's a way that the user can tell if it's been attacked. If you're on the defense side, you can look at logs. You can just see if you have those IDS, IPS policies in place. They all start screaming, kicking their feet, and sending you tons of emails saying, oh, we're dying, please help. Something like that. Here is a way that someone was monitoring it. So they had a script that literally listens for all inbound connections, and it was just sort of saying, oh, if someone connects to me, log it and make green legitimate users or data under a meg, red users data over a certain size, and all of a sudden they got a nice pretty graph, and if you search DDoS GIF, it comes up rather quickly. There are some non-recommended solutions for dealing with these that aren't, as I say, recommended under any way. Some companies will just buy a bigger pipe or a bigger bottle or more bandwidth. So when all of a sudden they'll go from 50 meg to 100 meg to 200 meg to a gigabyte, and if the DDoS script is very good or they have a big botnet, all of a sudden this doesn't work. It doesn't help. Because all of a sudden you just filled up your new expensive pipe with dummy data again. Or you can split it. So we have what are called a proxy server or a web proxy. So all of the data gets pointed to that web proxy, and then it is split out to different providers, different servers, everything like that. Most companies should have one of these if they are reasonably tech savvy and rather into their cybersecurity. They aren't overly expensive and they can be hosted in the cloud, which helps just separate and make sure overall infrastructure more secure. If you want to talk to us about that, again, hit us up on Discord. We're always happy to talk about weird, cool stuff like this because most of us run them. Our recommended solutions are if you have a proxy or something, move it to a cloud provider because they are meant and designed for accepting this amount of information. Cloudflare, they have one of the best DDoS protection out there. I'm never going to say anything's perfect, but it's one of the best. Contabu, HostPopper, all of these other things do DDoS protection as well. And if you Google it, you'll get hundreds of providers that are relatively up for trying to help you protect your website, your network, your anything you want to protect. Think of these as bouncers or bartenders that are sort of like filtering out the illegitimate traffic and sort of saying, oh, this bottle's bad, send it back. Or in the case of bouncers, nope, you don't have a valid ID, get out of here, that kind of thing. And then if you are managing everything yourself, you can then, as I say, implement these firewalls, intruder detection systems and intrusion prevention systems. These can be quite a lot of work to set up and integrate, or there are some free ones out there that if you want to start having to play with, you can. And think of this as, again, like a filter. So it looks at what IPs have been used against other DDoS attacks in the past, and if it says, oh, this one's connected, it says, I don't know about that, mate. You were dodgy in the past. Please go away, come back later. Or try another IP. And then mitigation tools that can be installed live on the servers or the hosts that monitor all this stuff as well. So what we've covered really has been what is denial of service attacks, what is distributed denial of service attacks, why it's done, and how you can sort of like mitigate it. If you want to have any more conversations with us, hit us up over on Discord or by our email, but we always prefer you to go to the Discord first. If we can get more traffic, more general conversation in there, that's great. And then all of us can put our combined minds together and put what we want in. And then Ryan's going to be taking you through a live capture the flag demo of cross-site scripting. So that will be on another stream. And that will be going through a live attack because that's what we heard that you wanted last week. So that's what we're going to try and do. So if you have anything that you want us to do or any topics that you want us to talk about, please let us know and we will try our best to do it.
Mention the feedback form.
Yes, we also have a feedback form now. We put one out last week. I'm not sure how many of you actually went through and did it, but we did get some feedback from it, and that's why we're changing it now.
The new one's in announcements as well.
Yep, as Ryan says, the new one's in announcements. So if you want to post the new link, or are we going to Discord?
I'll stream it.
Okay, so we'll have a new stream if you click the link in the live chat, and we will head over there. But thank you very much for coming to mine. After the Ryan's presentation, I will be back in the Discord along with most of the support team, so come and say hi and give us feedback, or if you just want to chat about any of the challenges, we're there. Thank you very much.